welcome to section 1.4 part 2, where we will be discussing the properties of algebra. Oh yeah, now last week we talked about the real number Death Star. There are some properties that exist in the Death Star that keeps it together. Maybe you want to call it the Force, I don't know. But today we've got to learn about these properties. Basically, we can pull out any 2 numbers or any 3 numbers or any 4 numbers out of the Death Star. It doesn't matter if it's from the core or from the weapon or from the integers or from the rationals. These properties exist for all the numbers in the Death Star. So let's go. Let's talk about these properties. The first one you need to know about is the associative property. Now, careful, don't ever abbreviate that one. It happened to me once. Bad news, okay? The associative property, and my key thing that you're going to want to remember with the associative property is parenthesis. In the associative property, it basically states that you're allowed to rearrange parenthesis and you'll get the same answer. For example, I could do parenthesis 5 plus 4 plus 3. And that would actually be the same as if I did 5 plus parenthesis 4 plus 3, as long as it was all addition. This property, associative, works with addition and multiplication. This is called the associative property of addition because it's all addition. Notice 5 plus 4 is 9, plus 3 is 12, and 4 plus 3 is 7, plus 5 is 12. You're going to get 12 equals 12. Boom. That is the associative property because it deals with parenthesis and moving of the parenthesis. This is also true with multiplication. We could do 3 times 2 times 8 and do these two first, or do 3 times and then do 2 times 8 first, and we'll get the same answer. The associative property of multiplication. Okay, so don't forget, associative property is moving of parenthesis. Moving your parenthesis. The commutative property, now that has the word co in it. The commutative property is all about order. You can change the order of things. See, since commutative has an O in it, think of it as order. We could do 5 plus 3. That's the same as 3 plus 5. That right there is the commutative property. It allows you to switch the order of things. Commutative, it's got an O, and it's got 2 things, and we're switching the order. Works for multiplication as well. 7 times 5 is the same as 5 times 7. That's the commutative property of multiplication. Good. Remember, that has 2 things, switching order. Okay. Associative, we move parenthesis. In commutative, we change the order. The distributive property. Oh yeah, I sometimes call the distributive property the dog pee law. That's a little inappropriate. But for those of you that have a dog, especially a male dog, I don't know if this happens to you, but when you let that dog go outside into the backyard, into the fence, into its fenced backyard, that dog pees on everything. It's like the nature of a dog to pee on everything. This is true with the distributive property. Let me show you the distributive property. If we had something like 3 times 2 plus 5, you could do the 2 plus 5 first and then times it by 3, or apply the dog pee law. Basically, we're letting the dog, who's outside the fence right now, into the yard, and that dog is going to pee or multiply onto everything here. So we get 3 times 2, which is 6, plus 3 times 5, which is 15. The distributive law is basically you multiplying all the outside values, all the outside value into all the inside values. Like we could have this one here, 2 times 5x plus 8. We would take the 2 in and we get 10x, and we take the 2 in again and get 16. There could be more than 2 things in the yard. Maybe we have 5, and here we have 3x minus 7y plus 11. Well, we could use the distribution law. We're taking the value outside and multiplying it to all values inside. 5 times 3x is 15x, and 5 times negative 7y, that's negative 35y, and 5 times 11, well, that's 55. This is an example of the distributive property. You have a value outside the parenthesis, it gets multiplied to all values inside the parenthesis, and then you have no parenthesis once you are done. Let's talk about the identity property. The identity property makes things stay the same. So if I had 5, there is a number that I could add to 5 so that it just stays the same. What can I add to 5 so that it doesn't change? You bet, 0. When doing addition, the additive identity is 0. And this is an example of the identity property of addition. Adding is 0. Let's do multiplication. If I had 8, what could I times by so that I just get 8? I don't change its identity. Hopefully you said 1. That's right. Taking 8 times 1 equals 8. And that's why the multiplicative identity is 1. And this is an example of the identity of multiplication. Okay, good. So remember, identity stays the same. Stays the same. Let's go to inverse. Inverse is all about undoing or doing the opposite. That's what the word inverse means. So for example, if I had 5 and I wanted to undo it so that I kill it completely, I want nothing there. 5 plus what would kill the 5? Well, the opposite of a 5 is -5. Yep. So 5 plus -5 would get me 0. That's an example of the inverse property of addition. We could do the same thing with multiplication. What would I have to multiply by to completely undo the 6? I want to kill it. I want to get rid of 6. What do I multiply by? Well, the opposite of multiply is division. And so we actually multiply by 1 over 6 to cancel it completely out. Notice the 6's would cancel out, and I'd just be left with 1. This is an example of the inverse property of multiplication. And it's doing the opposite. So remember, associative, parenthesis, commutative, order, distributive, dog pee, identity, it stays the same. And inverse is undoing or the opposite. Okay, it's your turn to play Name That Property. Okay, so here's how it works. Take out your notebook. We're going to be writing up some properties, and we're going to see if you know what the name of that property is. You can use your notes. Let's see how it goes. Here is property number 1. Pause your video, write it down. Let's see if you can name that property. Time's up. Hopefully you said that this is the commutative property. Commutative property of addition. That's what the name is. It's the commutative property of addition. If you got it, give yourself 10 points. Let's go to question number 2. Here it is. Question number 2, 17 times parenthesis 4 times x, close parenthesis, equals parenthesis 17 times 4, close parenthesis times x. Pause the video. Let's see if you get it. Time's up. This one here has got parenthesis in it, and so therefore its property name is the associative property. The associative property. And it's multiplication, so we would say of multiplication. Associative property of multiplication. Remember, it's got parentheses in it, so it's associative. Here's the next property. 27 plus a -27 equals 0. What property is this? Let's see if you get it. Pause the video, and we'll check it in just a sec. Time's up. Notice that we started with 27, and then we undid it. We undid it, and that got us 0. That right there is the inverse property. Inverse property because it undoes. Inverse property of addition. Here's the next property. 8 open parenthesis x plus 7 close parenthesis equals 8x plus 56. Pause the video now. Let's see if you can name this property. Hopefully on this one, this is a little tricky. We started with parenthesis and then no parenthesis. This is the distributive property. Notice that they took the 8 in to the parenthesis. This is the distributive property. Distributive property, aka dog pee. Number 5, here it is. This is the last one right here. 2/11 times 1 equals 2/11. Pause the video. Let's see if you can name that property. Okay, so we started with 2/11. We times it by a 1. We still have 2/11. So we didn't do anything. In fact, it kept its same identity. This is the identity property of multiplication. Well, there we go. Okay, we did 5 of them. Nice work playing Name That Property. The last thing that we need to discuss is this idea of like terms. In mathematics, you are allowed to add anything together that has like terms, like, wow, that's a horrible way to write like, sorry about that, like terms. For example, if I had 5 apples and I wanted to add that to 3 apples, can we put those together? You bet, because they're both apples. 5 plus 3, that's 8 apples. In mathematics, we're allowed to add anything together that's exactly the same. So the same rule would apply here with 5x plus 3x. Those are like terms, okay? And so we can add those together to get 8x. It's like saying that x-rays. 5 x-rays plus 3 x-rays equals 8 x-rays. Now you got to be really careful here because you might get a problem that looks like this. 6 apples plus 2 bananas. 2 bananas. What does that equal? Now some of you might, be creative and say, ooh, that's 1 smoothie, brother O. 1 smoothie. No. Okay, that might be true down at Jamba Juice, but here, when dealing with math, we are only allowed to add things that are exactly the same like terms. So if you were asked to add 6x plus 2y, you can't do it. You just say 6x plus 2y. This is just 6 apples plus 2 bananas. They have to be like terms to be able to add together in algebra. Okay, the variables, that is. What about what if we had something like this? I don't know. Here's one that messes people up. What if we had 5x squared plus 2x squared? Can we add those together? You bet. They're exactly the same like terms, and they're wearing the same hats. Okay, as long as they're wearing the same hats, we can add those together. That's going to get us 7x squared. Their hats don't change. So if it was 5 baseball cap guys plus 2 baseball cap guys, you bet we can add those together, giving us 7 baseball cap guys. But the hats have to be the same. If you had an 8, I don't know, Abe Lincolns, and then you did minus 3 baseball cap guys, you can't add those together because they're wearing different hats. So 8x cubed plus 2x squared, can we add those together? No way. They're not like terms because they're not wearing the same hat. You might be asked to simplify an expression by combining like terms. Anytime you have to simplify an expression by combining like terms, the first thing you should do is use the distributive property, distribute, and then combine like terms. Let's try this example here. If I have 3, I'm going to dog p it in. I get 6x. Dog p it in here. I get plus 21. Here, ooh, be careful. The dog is negative 2. Some people leave out the negative 2 and they think the dog is just 2. But here it's negative 2 and we got to distribute that in. So negative 2 times 4x is minus 8x. And negative 2 times 1 is minus 2. So now that we've distributed, we can combine our like terms. We'll combine our x's with our x's. Ooh, that sounds like a song. Combine my x's with my x's. Why not? I don't know what that song is. Oh well. 6x minus, it's something my daughter listens to. Combine my x's with my x's. Why not? I don't know. 6x minus 8x is negative 2x. And then I can add my numbers together. 21 minus 2 is 19. And that's our answer. So just be aware, you are allowed to combine like terms, but they got to have the same hat. They got to be the same variable. And if you've got parentheses, you'll want to make sure to distribute before. Let's give you guys 2 problems to work on, and then we'll be done. Here's question number 6 and number 7 for you. Go ahead and take out your notebook and give these 2 problems a try. When you're ready to check your answer, unpause the video, and we'll see how you did. Okay, let's start off with number 6. First thing we got to do is distribute into the parentheses. So we're going to take this negative 2 in. Negative 2 times 4x is negative 8x. And negative 2 times a positive 3 is minus 6. Here we're taking in a negative 3. So negative 3 times 2 is minus 6. And negative 3 times negative 7 is plus 21x. Now we can combine our like terms, our x's with our x's. So 21 minus 8 is 13x. And negative 6 minus 6, that's negative 12. Ooh. If you struggle with that, you can use your calculator because it's negative 6 and then minus 6 more. Okay, there's our answer. Number 7, let's distribute the parentheses. Ooh, a little harder here. We're going to have to use our laws of exponents. Negative 4 times 3, that's negative 12x to the, what do we do with our exponents? Hopefully you haven't forgot that from part 1. You bet. It's add. Then we take our negative 4 in. So negative 4 times 2, that's negative 8x squared. And then we got plus 5x to the 5th plus 7x squared. Now I can combine my like terms. These guys are wearing the same hats here. So negative 12 plus 5, that's negative 7x to the 5th. The hats stay the same. And then negative 8x squared plus 7x squared, those are combined like, those have the same hats. And so we can add those. Negative 8x raised plus 7x raised is negative x raised. And it was squared. And so don't forget to put that. Well, that's it. Nice work there. Thanks for participating in section 1.4 part 2. That's it for chapter 1. So next time we get together, it'll be time to review for the celebration of knowledge. We'll see you then.